and thank you for the opportunity to present to you all today during Rail Safety Week on the very important topic of improving safety at railway crossings. So for those that I haven't met, I'm Julia Pitsopoulos. I head up a consultancy called HFRM, or Human Factors Risk Management, and we've been operating for about 17 years, supporting safety critical industries to optimise human performance. So we're a team of specialists with qualifications in organisational psychology. We've got quite a lot of experience in safety critical sectors, particularly rail, but also aviation, healthcare, marine and roads. So we work with clients to enhance safety by considering the systems and the culture within which people operate and the performance shaping factors that really influence that day-to-day behaviour. So by understanding human behaviour, we take more of a holistic and systemic approach to optimising safety by setting people up for success so that they can perform accurately and safely within their environment. So the project I'll be taking you through today is a toolkit that we've developed on behalf of the Victorian Railway Safety Steering Committee, or VRCSSC. So this tool's designed to support those making decisions about railway upgrades to crossings. It really helps them to fully understand the users that are interacting with the crossing. So this could be road users, it could be pedestrians. We've got a tool for each of those types of crossings. It helps the people that are involved in making decisions about upgrades to methodically work through the factors at that crossing location that may influence the user's behaviour or may increase risk to the users. What it does is it provides checklists to use when assessing the human factors risks that exist at a crossing, and it then provides a human factors risk profile for a crossing. And that can be used as one key input to making decisions about which risk management controls are going to be best in order to reduce the identified risks. It does provide a one-stop shop that pulls a lot of the human factors evidence and literature together. So it enables people to have all of that information in one place to work through the pros and cons of different design solutions, depending on the user profile and the human factors risks at a crossing. So as you can see up on the screen here, we've worked very closely with a number of different stakeholders on this journey. And in particular, I'd really like to acknowledge the key sponsors of the project, being Darren, Donna and Dora, as well as the team at the opposite. So in a moment, I'm actually going to show you an overview video that takes you through the tool and its features, and then I'll give you a quick demo of the tool itself. So I'll just load up the video.
The Victorian Railway Crossing Safety Strategy Committee, or VRCSSC, continue to lead the way in upgrading level crossings in order to save lives and reduce incidents. Determining which crossings to prioritise for upgrade, as well as choosing the most effective design, can be complex. We must consider the risks, the opportunities, such as major project works occurring nearby, the incidents that have occurred, and the cost versus benefits of various design solutions. To design the most effective upgrade, we must understand the users that are interacting with the crossing and the factors that influence their behaviour. Let's consider some examples. In their haste to catch the train, pedestrians may bypass an emergency exit gate or take a shortcut across the tracks rather than cross at the crossing. Users are influenced by desire lines, that is, seeking the shortest possible way to their desired location. Factors such as social influence and diffusion of responsibility also play a part, such as, they're doing it, so it must be okay. Users can also be unintentionally caught in a queue across a live rail line due to a range of factors such as the design of the crossing, the volume of traffic at the location, the complexity of the road infrastructure. By applying human factors and systems thinking, we can put ourselves in the user's shoes and understand why certain actions may make sense to them at the time. We can see how they are influenced by the design of the crossing and the infrastructure and features around them. This helps us to design a crossing upgrade that achieves the safest outcomes for those using it. There is a wealth of human factors research that can help to assess and identify the risks. However, it is challenging for those responsible for designing crossing upgrades to know where to find and how to use this information to help them to make informed decisions that optimise the crossing design. Therefore, the VRCSSC has pioneered the development of a one-stop shop for human factors guidance when it comes to level crossings. Through wide consultation, 2 interactive human factors tools have been developed, one for pedestrian and one for roads level crossings. Through the application of these tools, a human factors risk profile can be created for a level crossing. This helps to achieve optimal design solutions for upgrades that understand and manage human factors risks, are based on evidence from desktop and on-site reviews, and that can be integrated into the overall crossing design early enough in the life cycle to avoid costly redesign. The human factors tools are structured around the design life cycle of a crossing, from prepare to assess to design, through to the build and maintain stages. The desktop review assesses the human factors risks at the crossings, using data such as ALCAM, incident information and community feedback. The on-site review provides an observer checklist to systematically assess how users are interacting with the crossing, the profile of the different user types, their actions and behaviours, including any risk-taking behaviour that is observed. Detailed information is provided in the guidance notes to help the user understand and assess the human factors risk factors by simply clicking on the relevant factor. Once the review is completed, an overall human factors risk profile for the crossing is automatically created on a visual dashboard. This information can be used to feed into broader risk assessments. This provides an informed foundation for making risk-based decisions in relation to the priority level of the crossing upgrade and the most appropriate combination of controls to include in the upgrade. This might involve strengthening existing controls at the location and/or introducing new controls. The user can click on further guidance about the pros and cons of risk controls from a human factors perspective in order to support effective decision making. The information in the human factors tools can be printed and saved electronically. The human factors tools make it easier for designers, safety, and human factors professionals to effectively understand and manage human factors risks by providing an interactive one-stop shop. The tools help to optimise safety, cost benefit, and regulatory compliance. They should be used when prioritising which level crossings to upgrade and when making decisions about the optimal design solution for the upgrade. The human factors tools are a great advancement in the rail industry as they make it easier to accurately integrate human factors and systems thinking in order to optimise the safety outcomes of the level crossing upgrade program.
So as you can see through the video, it gives you a bit of a what, who, where, why tour across the video. You know, why have we developed it? Who's using it in the industry? Who can benefit from using the tool, as well as how the tool actually works. So we've got a couple more minutes. So I might just put the tool up on the screen and you can just have a little bit of a look at the tool itself. All right, so I'm not quite sure if you can see it in terms of on the presentation here, but it's actually built on Excel as the foundation. Eventually, we'd like to move it to a web-based app. However, we've really extended the boundaries almost of what Excel can do through this program, and we'll just take you through a step-by-step process of how it works. So you click on the Start button, it gives you some instructions for use, and then you can go off to the home page. Now the home page provides you with that process flow across level crossings upgrades. What do I need to do to prepare? How do I assess the human factors risks? How do I then select the appropriate combination of controls and recommend controls for application at the crossing? And then it also takes you through some of those human factors considerations at the construction and build stage, as well as how to continue to monitor and maintain the effectiveness of those controls. So if we look into the assess phase, we can look at the fact we've got a desktop review. So that desktop review is structured around some key aspects of human factors, things like the crossing characteristics and how that influence performance, right through to the user types, the types of awareness characteristics, sighting characteristics, circulation, and so on. And with any of these aspects, you can simply click in, go, okay, I need to know a little bit more about it. So you might decide you need to know a little bit more about what we mean by crossing characteristics. You can simply just click in here and it takes you to the guidance material. So it takes you through what you need to look at when you're considering the characteristics and the users. So for this one, this is the desktop review. It feeds in a lot of what's in the LCAM model, which is fantastic. So you can drop down and look at the volume types, the train speed, and so on. So a lot of that information is available already. So we build that in. And then we go to the on-site review. Really, really important to get out onto the actual site and to have a look around. You know, some of those things that we might think aren't a problem actually have become a problem. Things like visual obstructions, for example, that might mean that the visibility at that crossing isn't ideal. So again, it's got a whole bunch of different parameters that you go through and you look at whether you can assess the adequacy from those particular lenses. So once you've done all of that, you take some notes and that takes you through to the human factors dashboard. So you can see here that you get a bit of a feel for where you need to focus effort and attention. And that feeds into the broader risk assessments that you're conducting. So it's really important to stress that this tool should not be a standalone decision-making tool. It really feeds into those broader risk assessments in order to give you more of an ability to make informed decisions about what the optimum design solutions should be. And you can print this information and bring it to your risk assessments. You can look at if certain things have come up as an issue, so sightings come up as an issue, it then starts to help you to channel or focus in on what are the control options that might be particularly useful for those particular risk areas. So you can click in yes or no, and it will highlight things accordingly. You then go into the recommendation of controls. So again, you're using all of that information to culminate into do we have adequate controls in place, or do we have controls in place, like signage, for example, but it's not adequate, it needs to be improved. We may find that we need to recommend an additional control, so tactile ground surface indicators were recommended at this particular site based on the assessment, or we may decide that there needs to be some more research and explore further whether a control might be suitable because you haven't got the adequate data available to you, or you can simply reject a control where you feel it's not suitable based on the data. So it really starts to shape your control selections. I showed you a little bit about the guidance. You can click into the guidance at any point and you can get a bit more information about these human factors characteristics that you're looking at. And you can also get a lot of information about the controls. So, what are the pros and cons of different controls and what are the human factors considerations of these different controls. So it really tries to compile all of that information that exists into a one-stop shop. And again, really important that we continue to research and make sure that this information is up to date. There's some areas that don't have enough information currently, and there's some areas where we know further research has occurred, and that can continue to fine-tune and shape this information. All right, so look, again, thank you for the opportunity to share this with you. It's really important that we continue to evolve this. At the moment, it's being developed through the VRCSSC down here in Victoria. So please do reach out to the committee members, to Darren or to Donna if you need further information about the tool.
Julia, thank you very much for a very brief, albeit terribly interrupted overview. So we will provide a copy of the recording, but also we'll have a chat to the Victorian Committee about providing access to the video, which explains the tool in a little more easily digestible way. So thank you very much. A really great initiative of the committee. I really commend them from looking at level crossing safety from this slightly different perspective.
Thanks, Heather. Thanks all.
Thanks. So I'd just now like to introduce Natalie Loughborough and Paul Bennett from NTRO. And if Natalie and Paul, you want to join us on the screen. Natalie and Paul are going to talk about a new project that they've been involved in, which is looking at the feasibility and impact of secondary augmented warning systems. So Paul and Natalie, have we got you there appearing?
You should have us, and we should be sharing at the moment.
I can certainly see your screen. Okay, I'll hand over to you.
Perfect. Thank you. Thanks, Heather and Hope, for the invite to be here today, and obviously to be part of Rail Safety Week, and particularly important for us across the industry. I'm just going to take a moment or two of your time to talk a little bit about our organisation. Are my slides moving there?
Not yet.
Just one moment. Technical issues. There. Okay.
Now
You should be able to see now. Right, perfect. So I'm just going to take a couple of moments just to talk a little bit about the organisation, but the meat of the detail we'll share today, my fab colleague here, Paul Bennett, will be taking you through. And it might play a little bit into that space that Brett was making the comment on in terms of that passive level crossing space and some of the potential solutions that there are. So just our organisation, National Transport Research Organisation, we are a not-for-profit and for-purpose organisation, primarily serving the organisations that you see on the screen, but we do work across both public and private sector, but always with that view of how can we best help industry and how can we assist with best spend of public purse, most efficient and effective use for making improvements with transport solutions.
Sorry, it's $80 or more, you get a further $20 off.
Oh, sorry, if I could just ask for, I think it might be Brett trying to come on there to go onto mute. So we aim at being a multimodal organisation, so we deliver solutions across the board, and really that helps in this space of level crossings to bring together that road and rail interface and ensuring we really have that multimodal picture. Our legacy as an organisation is primarily in the road space, but recently moving into that space around covering road, rail, ports and airports and looking across that picture. Our organisation, though, isn't based in a modal structure. We have disciplines and we work across all of those disciplines that you see on the screen at the bottom to look at how we can pull from our great expertise, both academic, engineering and more broad business sense, to come up with solutions to the challenges presented to us across the board. So without further ado, that's just to give you a bit of a flavour and a bit of a foundation for our organisation. But I'm going to hand across to Paul Bennett, who's our fantastic team member who's been leading the augmented secondary level crossing warning system project.
Okay, thanks, Natalie. So this project is currently underway. And there's quite a number of participants, as well as NTRO. We have the ARCS group that have been helping us put together the system. Traffic Technologies have been helping us with all the commercial off-the-shelf equipment. And One Wi-Fi have been helping with their cameras set up at the control site. A number of co-funders and in-kind supporters, VicDTP, ARTC, Victorian Railway Crossing Safety Steering Committee and the Railway Crossing Technical Group. And the trials were conducted in New South Wales, so we needed permission from Transport for New South Wales, so thanks for their support, as well as the local councils. So the trial site is within Greater Hume Council and the control site is Winge Carriby Council. So thanks for their cooperation and assistance in helping us run these trials. So passive level crossings, what is the problem? Well, there's heaps of them. They're in rural remote locations, controlled only by static passive stop or give way signs, and trains can be very infrequent. So you have motorists unfamiliar with the road who may not be aware of the level crossing ahead, as well as motorists who perhaps drive the road every day and may become complacent. And it only takes that one time for them to be an actual crash. The consequences of that, of course, fatalities and injuries to motorists, train drivers and passengers, train derailments, road and rail closures, and all the trauma of that and the economic impacts, particularly if the road and rail are closed for some time. So we know that installing RX5 flashing lights at level crossings together with active advance warning signs on both road approaches is known to increase stopping compliance by around 40%, so from a passive to an active level crossing, where passive is around 50% and active can be around 85% compliance. So this project aims to understand road user behaviours at an active level crossing versus an augmented warning system, passive level crossing, augmented being that the system we're setting up augments the stop sign. The effectiveness of building commercial off-the-shelf or COTS-based augmented warning system and the effectiveness of using VMS as part of that augmented warning system. So we're after a solution that's cost-effective and easily deployable, and can be moved from one site to another, and appropriate at level crossings where the volumes of traffic don't justify active controls like RX5 flashing lights and the active advance warning signs. But our system provides similar advance warning. It's self-contained, being solar powered, so there's no trenching required and it's easily transportable. So you can see there the augmented level crossing warning system consists of a number of these traffic warning signs or traffic operations monitors. So we, as I mentioned earlier, it's transportable. In this case, we've got a big yellow cage you can see there full of weights, and the way to move them is to unlock the padlock, open the cage and take those weights out, and that helps you to move it from one position to another if needs be. On that, of course, you can see the pole, which we've got mounted the VMS with the various messaging that it displays. Within that is a radar that can detect vehicles 200 metres in advance of this sign. So that's measuring the speeds of approaching vehicles. There's a camera there. That particular camera has ANPR, automatic number plate recognition capabilities, but we're not actually using it for that sake. And we've also got the solar panels there and the battery you can see to keep it powered. There's a modem as well, so the vehicle counts and speeds from the radar, we can receive those to an online dashboard over 4G. And just some examples of some of the bar charts and pie charts that you can see on the dashboard. This is the trial site on Odwins Road. You can see it's also got a short stacking issue, the distance between its T intersection with Olympic Highway, so and there's only 27 metres between the crossing itself and the highway. We weren't actually looking at that issue, but the yellow square there you can see is the location where we put the traffic warning sign, and the crosses mark all the cameras that we use to observe traffic. It's important to remember that during the trial and in any case that the stop sign remains the legal control, so it's just augmenting that. So part of the reason we chose this site was ARTC had actually previously done a study at this site before we had any augmented warning system in place. And they use what's called the Road User Behaviour Data Collection Module, which uses CCTV and AI modelling to detect violations of vehicles not stopping at the level crossing. And they actually found that at least 53% of drivers were not stopping at this passive level crossing. So that means no more than 47% were compliant. So a bit of a concern there. I should mention that they partnered with a company called AccuSensus for their technology there. So our trial, you can see in the image on the left there, you can see where we located the sign and the cameras. So there was the ANPR camera at the front of the sign, and we also had a little UFI security camera connected to the back, as well as one at the level crossing. It was actually where that little trailer in the previous slide from the ARTC study was placed, and the other camera further up was capturing vehicles as they were approaching the sign. So I'll just play one of the videos. So yeah, that's just an example of what the camera at the stop line was capturing. And yeah, the smarts within it were such that the radar detects the speed of the vehicle. If the speed is 65 kilometres an hour or above, the messages slow down. Between 50 and 65, stop ahead. 30 to 50, LX ahead. Most people know that LX means level crossing, and less than 30, stop for TOM, and TOM means traffic operations monitor, which is another name that we gave to this traffic warning sign. And we'll be looking at different messaging in upcoming trials. So the control site was another site, active level crossing in New South Wales. This one in Glen Quarry, which is part of within the Winch-Carriby Shire Council. So this one has the active advance warning signs 185 metres in advance of the crossing. You can see the one on the left has the flashing wigwags that activate when a train is detected. So installation requires trenching all the way to the railway line. There's some conjecture that when motorists see the lights come on, for some it's a signal to speed up, try and beat the train. So that can be a bit of a concern with these flashing wigwags. And yeah, you can see on the image on the right, if you've got the RX5 flashing lights to the side and overhead at the crossing itself. So One Wi-Fi was the company that helped us at this site. They set up their camera. So it's just a very similar, self-powered with solar panels, a camera on the front and modem. So you can see the image on the right there is what they were capturing there. And they had a detection zone. So it was a movement sensor video camera to capture typical driver behaviour on approach to the level crossing that's controlled by flashing lights. So we're particularly interested in the vehicles that are approaching as the flashing lights come on and when they're on. So it autonomously monitors, detects and reports objects, observe vehicles that are approaching when the flashing lights are active, and it was sending timestamps of each vehicle entering the detection zone and recording those that stopped, how many seconds they stopped. So similar to the Oddwins Road site, that data was sent to us to an online dashboard over 4G. Initial observations, so we've actually just received all the equipment today, having had it all collected from the contractors from Oddwins Road yesterday. So the field trial is only just finished, and the next stage is the AI analysis of all the vision. But our initial observations, just from looking at individual clips of vehicles approaching, is that more and more vehicles are actually stopping at the level crossing. So these security cameras are activated when they sense a vehicle. So each clip is a vehicle approaching. So next steps, as I mentioned, the field trial finished yesterday at Oddwins Road, and we'll conduct the AI analysis on the vision recorded by the security cameras, and that'll give us actual measurable improvement in compliance. The There's plans to conduct 2 more trials, one in Australia and one in New Zealand. But these sites, unlike Hodgins Road, which is a straight flat road where you can see the level crossing in advance for quite some distance, we're looking for sites where there's a bend in the road or there's vegetation or whatever reason, the site distance to the actual level crossing is actually quite short. So in those trials, we expect that drivers will actually see the traffic warning signs, the VMS, before they actually sight the level crossing. And we'll trial different messaging in that case as well. A human factors assessment of determining what messages are most effective. But again, we'll have different messaging depending on the speeds of the approaching vehicles, different messaging for those that are speeding as opposed to those going at a reasonable speed. So that's our presentation. I think we've got a couple more minutes to answer any questions.
Thanks very much, Paul and Natalie. We've got a couple of questions here. So Daniel's asking, does the system consider and warn other modes of transport such as bicycle and perhaps horses as well?
No, it really just is the radar detecting approaching vehicles. So I guess
it's something, I was going to say it's movement sensor, so it's probably something that we would have to look to maybe trial and see what happens in those circumstances. The data that we've collected that's come back to site that we're just about to go through and analyse might give us some insights into that. So happy to come back if we collect any data that shows that that is the case. Probably more likely that we would experience maybe bicycles crossing than horses, but who knows? Let's see what the data tells us, and if we get that detail, we're happy to share as we have some of that analysis done.
Thanks, Natalie. Tom asks, do you think improved compliance levels would remain should the solution be rolled out on a broader scale? So is its novelty part of the contributing to the compliance? Yeah,
that's an interesting point, and we discussed that at a previous meeting. What's the retaining of compliance if it does improve? We might, with the camera set up, leave them. We're going to collect compliance at the next trials before we set up the sign, but we might actually also collect it after as well and see if there's a difference between before and after in compliance. And is there residual compliance coming from the warning sign, or does it wear off?
And I think there's probably also a piece there in the segment of people using that, and again, something more we can test in the analysis around, is it regular users who are likely to act differently from those who are coming to it new? Clearly, those who are new to the area, it's only going to influence whilst it's actually in place. So I think there's a whole host more different angles that we can look at as we put further of these trials into place. As Paul said, we've got another 2 to go that we're figuring out sites for at the moment, but again, staying on that focus in the passive space. So we can start and test some more of these things as we roll out further and feed that back into the industry, and you know, maybe even becomes a feature within the work that Julie has been suggesting. I think all of these things start to link up very well as we have more data and more information as to how things work.
So in terms of seeing these sorts of this sort of project roll out on a broader scale, John's asking the important question about cost. Do you have any indication that you can give about cost per unit per site?
Our next trials, we're going to trial different VMS. So I'm reluctant to give a fixed cost at this stage, but the idea is it's all commercial off-the-shelf kit that we put together. So in that way, it's trying to be a cost-effective solution as best as possible. So,
and I think that's the key thing with any of these, keeping the cost down as low as we possibly can, and getting to a place where, you know, the first trial, there were lots of different moving parts and individual components. The same contractor didn't introduce the whole picture. NTRO pulled that together, or ACRI as was. And therefore, I think trying to get to a space of how you figure out how the components work together will start and make it more and more cost effective as potential rollout. But of course, there isn't a as we know, no silver bullet, and one size doesn't fit all in these circumstances. So the more we can keep it flexible but keep the costs down means that we can meet the needs of the particular sites and address the issues at those sites. So I'm loath to us to get to a place where we say this is the only solution it can be, because that takes away some of that adaptability that can, in my mind, help with some of the peculiarities of different locations, different circumstances that we'll be able to assist.
So a question just about 4G. Does the 4G transmission have redundancy built in?
That's a good question. I don't.
I'm looking at you, Paul, because I don't know the answer to it.
No, it doesn't. But I mean, in this case, in this first trial, we've stored all the vision that we need on SD cards as well in the cameras. So that's the backup, I guess, that we have. Yeah.
And perhaps just related to that a little bit, Graham's just asking a question is, so if these were rolled out more broadly, would the cameras actually be needed in the final solution, or are the cameras really just part of the research component?
Yeah, no, the cameras are just part of the trial to measure before after compliance. So yeah, assuming that the trials prove that they're effective, then all you need is the warning signs in place.
I guess the only other angle of that, but it's not specific to the solution, it's more about the security piece of equipment and where you're locating. So some of the camera use can also help with some of that, I think. So I think, again, it's assessing per site on the different risk elements that we have, and again, building it in if needed and not building it in if not, but it certainly wouldn't be needed to capture the movements, because that's not what the purpose would be at that point.
Graham's just asking a question about, and this might be our final one, is the short stacking approach data different from the other direction?
Oh, yeah, I just mentioned that is a short stacking site, but the trial has nothing to do in this case with short stacking. So we don't have any particular data on the short stacking. But that is, short stacking is something that we consider looking at in future projects, actually. Yeah.
Great. Look, I know there's some questions there that we haven't had the chance to actually get to. I'm sure Paul and Natalie wouldn't mind you contacting them if you would like to discuss the project and the technology some more and get the answer to some of your more technical questions. Hope that's okay, Natalie and Paul.
Yep.
Absolutely.
Yep.
By all means, share details, Heather, if anybody hasn't got them and needs them.
Thanks. If you wouldn't mind dropping those, just your emails, perhaps in the chat, that'll be really helpful. Look, thank you very much. A really great project, and clearly you can see it's a much cheaper option than some of the other technologies that have been used, and I think provides real positivity that we've got another option that in some places this is going to really help people do the right thing at the crossing and stop. Thank you very much. We might just move on to another road-based technology, but very different in style and approach. I'd like to introduce John Wall, who's Senior Manager for Road Safety Technology at Transport for New South Wales. And John's going to be sharing with us some information about a project they've been doing south of Sydney. So John, if you'd like to join us online, both your camera and your voice.
Thank you, Heather. Hopefully you can see my title slide.
Yes, we can.
All right to go. Great, thank you. Well, good afternoon, everyone. Before I start, I'd like to pay my respect to elders past and present and recognise and celebrate the diversity of Aboriginal peoples and their ongoing cultures and connections to lands and waters of New South Wales. So today I'm coming to you from Dharawal country, south of Sydney in the Illawarra. Just a little bit of a snapshot of the level crossing issue in terms of crashes and casualties. And this is the rail-based data rather than the road crash data that I'm usually used to working with. So we know here in New South Wales there are around 2,700 level crossings, of which 1,307 are on public roads. and the remainder are on private properties such as farms. Of those 1,307 public rail level crossings, there are 449 that are active, but are 858, so the vast majority which are passive crossings, consisting just of a stop sign or a give way sign or something similar. Active crossings, we've got 298. Oops, someone's taking control of my slides. Okay. That is strange. Try again. So the majority of the active crossings are boom gates and flashing lights. We have some that are just flashing lights and a couple of manually operated boom gates as well. The passive crossings, 858 stop or give way signs. So between July of 2013 and June of 2023, we had 59 collisions between trains and road vehicles, resulting in 7 fatalities and 10 serious injuries. So these statistics come from the Office of the National Rail Safety Regulator, or ONSAR, is a custodian of that data. A little bit about my team. Our team, the Road Safety Technology team within Transport, is part of Transport Safety, and our mission is really around discovering and deploying technologies that significantly reduce the risk of death and injury to New South Wales road users. So I'm a roadie. That's where I'm comfortable. I've had a little bit to do with rail, but I think for the rail safety people that are online this afternoon, road safety and the road network is the Wild West compared to the much more controlled system that you have within rail. But I'm wondering if there are some of the things that we're doing in that space that could directly relate to improving rail level crossing safety, that interface between the rail network, which is very well managed and tightly controlled, to the Wild West network, which is the road network around the state as well. The first one I'd like to talk about is our Speed Advisor application. The Speed Advisor application is a form of intelligent speed assistance, and simply put, it's ISA is a system that alerts a driver when they exceed the legal speed limit of the road that they're travelling on. We're seeing this come into play in a lot more vehicles these days, so built into the vehicle. In fact, it's been mandated in Europe now for European vehicles, for new vehicles in Europe. Ours is a smartphone application. We released it way back in 2014, and we've got over 125,000 downloads of this application to date. It only works in New South Wales, but it covers all of our 275,000 kilometres of network. That includes the state road network, as well as the local road network managed by local government as well. So as I said, it warns the driver when they're speeding. And one thing that we did back in June of this year is that we added an extra function to Speed Advisor, and that is a rail level crossing warning for the more than 1,300 locations that are on the public road network in New South Wales. So now as you approach a rail level crossing, if you're on a public road, you'll get a message to say that there's a rail level crossing ahead. Another piece of technology that we've been working on is our Road Safety Incident Investigation Camera, or RosieCam. RosieCam is a portable system. You can see it there on the slide. It's very easy to pick up and move. Similar, I guess, to the system that NTRO have been testing. Ours is a lot smaller. It measures the time to collision, collects vehicle speeds, classifies road use and movement codes, and assigns a severity rating to the incident. So we know there's a lot of places on our network where we get feedback from the community say this is a really dangerous spot a dangerous intersection or a dangerous pedestrian crossing, for instance, or perhaps even a rail level crossing. But we don't have a lot of crash data to support, I guess, the investigation of treatments for those particular areas. And funding often these days is also attached to having crash data that you can use to build your business case for a treatment. We've got a huge road network, only limited funds to actually do road safety treatments. RosaCam allows us to catch some of that near-miss data. And this is an example of one of the places where we were testing it, not with heavy rail, but actually with light rail in the Sydney CBD. This was for a period, I think we've got there about 4 weeks or 5 weeks or so of data. We had a few weeks where the system wasn't working properly, so it's an extended period. During that time, we collected 45 near-miss events, of which 20 were deemed to be severe near-miss events as well. The maximum speed, this is a 50-kilometre zone. The maximum speed was 45, so we know that the vehicles involved in this, and when I talk about vehicles in this context, a pedestrian for us is a vehicle in this particular context as well. So this includes pedestrians and cyclists and even scooter riders in terms of some of the e-scooters and things that we're seeing on the network at the moment as well. We importantly not only just capture vision of what's actually happening at that site, but we use the AI to process that vision to give us data that we can then go off and analyse as well. And this is a snapshot of some of those events that we actually captured at this particular place as well. I'm going to show you one here. This is one with an adult as a pedestrian. It was classified as a severe event. It's got a code there. My column's a little bit out, but this here is our time to collision of about 1.2 seconds. So let's have a look at this. So the time to collision, or what we call the post-encroachment time, is when both vehicles are in the same spot at the same particular time. And you can see this is a pedestrian and a public transport. The type is a tram or light rail vehicle, as we call them in New South Wales. The user type, the pedestrian, was an adult. We can classify whether it was a child as well. Let's have a look at the event. So it may be a bit stilted being online and being on Teams, but there was only 1.2 seconds between that pedestrian and that light rail vehicle being in the same place at the same time. So we classified that as quite a severe near-miss event. We've also been working in connected vehicles for a long time now, for just over a decade, and we've been looking at a specific technology called dedicated short-range communications. This is a system that is attached to an existing active level crossing. This particular one is a boom gate configuration. We have a solar powered system attached to that. And what we do is we're able to take a signal off the sensor, the points that are used to detect the train approaching the crossing. And that goes through a special radio system, a DSRC system, that then pushes out an alert to vehicles as they approach that crossing. So it picks up, the train is coming, pushes out an alert to say that the crossing is actually closed. And then that's picked up in by a special radio within the vehicle and displays a message on a dedicated display. This is quite different because it's a hybrid solution as well. So not only are we using a dedicated short-range communication radio, this radio works on a special frequency of the radio band in what's called the 5.9 gigahertz section of the spectrum. So very much like Wi-Fi that you have at home, but this part of the spectrum has actually been allocated by ACMA, the Australian Communications and Media Authority, as a public safety radio network frequency. And we've aligned with Europe and with the US. So this is an international standard for this particular part of the spectrum. It does require, though, fairly expensive radios to be in the vehicles, around about $3,000 for a radio. And when we first started this research about 10 years ago, we had a lot of manufacturers putting forward that they would be installing these radios in vehicles when they were manufactured. But sadly, only one mass market model of car has actually come to market with a DSRC radio in, and that was the Volkswagen Golf, produced in 2020 in Europe. And when that vehicle came to Australia, the DSRC radio was either disabled or wasn't present in the vehicle in the Australian model. So we're seeing DSRC as not something that vehicle manufacturers are embracing, but we are seeing them embrace cloud connectivity. So many vehicles that you purchase today will be connected to the cloud through a SIM card or an eSIM within the vehicle. They may be using something such as Android Auto, Apple CarPlay, or Google Auto, which is a built-in system as well. And that enables the vehicles to get messages through the cloud. And this particular system pushes out not only DSRC signals, but cloud-connected signals as well. And we're compliant with the ITSG5 message type, which is a specific message type for DSRC in Europe. There's also a number of trials that my team are not involved in, including our rail active crossing system. This is a $1.2 million trial of new digital technology to improve level crossing safety in rural and regional New South Wales. The technology, which we're calling RACS, the Rail Active Crossing System, it's modular, low cost and wireless, and it's designed to turn passive crossings into active crossings as well. It uses both flashing lights at the crossing as well as a wireless train-activated advanced signage. If the system does go down, in that rare case, the system automatically enters a stop sign mode and it becomes like a normal active crossing as well. We also have trials underway, again, by a different team in transport to enhance stop sign visibility, and this is at passive rail level crossing systems. There's a couple of treatments, a vehicle activated warning sign, so an advanced warning sign, a vehicle activated warning sign, and an enhanced stop sign at the crossing itself, and then an enhanced stop sign at the crossing. So 3 different treatments. Look, we've got some very positive results coming out of that. It's only early days, but there's been some positives with increases in stop sign compliance and decreased approach speeds, but it'll be some time before we have enough evidence to determine the effectiveness of these particular treatments. The vehicle activated warning sign, which you can see in the slide, doesn't have to be in the rail corridor. And as a roadie, I know it's a lot easier to do stuff on roads than it is in the rail corridor. So there's some advantages in terms of the time that it takes to install these signs as well, and the complexity around the design and approval process. And then, of course, we've got our standard level crossing improvement program that Transport for New South Wales is running as well. And that's providing, through our level crossing improvement program, accelerated upgrades to level crossings, assessed as a priority for safety enhancements. And we also use it to fund road safety education campaigns and enforcement initiatives as well. In the financial year up to 2031, 2032, we've got around $7.3 million locked in for funding for each financial year right up to the 2031 to 2032 program itself. From 2011, so this program's been going a long time, We've funded 71 major level crossing upgrades in New South Wales, 29 active to active upgrades, that's installing boom grates at sites which already have flashing lights, and 42 crossings have been converted from passive to active upgrades as well. This is our education program that's associated with that. And of course, we've got our level crossing improvement program enforcement, where we're actively involved in increasing enforcement around rail level crossings as well. There's my contact details if you want any more information about what we're doing. And Heather, back to you in the studio, I think.
Thank you very much. Thanks very much, John. And if you wouldn't mind just dropping your contact details into the chat box, that just might make it easier for people to have it at hand rather than looking through the slides. Just a couple of quick questions before we close, John. From Tom's asking, and the DSRC and 12V, is the thinking to implement these via smartphones or direct to vehicles?
So DSRC is direct to vehicles. That's the way that it works. So you need a dedicated DSRC radio that runs on 5.9 gigahertz. 10 years ago, when we started this research, a lot of the manufacturers, including Toyota and General Motors, had flagged that they would be installing these systems in the vehicles at the time of manufacture. That hasn't occurred. So the other way of doing it is that through a cloud-connected device, and certainly a smartphone is a way that we could do that in terms of things. And if we look at something that's a little bit live in terms of warnings, say the Waze application that some people may be aware of, in the future could have that capability, but none of the systems that we've got at the moment actually have that. So Google Maps, Apple Maps, the common ones that we've got don't have that capability, but there's nothing to say that if there's enough demand, and I guess we'd have to talk about worldwide here because they tend to be international products than statewide products, we could do that. Or someone could develop an application that is specific, similar to what we've got with our Speed Advisor application as well. But then everyone would need to have that application. So I think building it into an existing navigation app, like Waze, for example, where we already have hundreds of thousands of users of that application on their smartphone in Australia today, would probably be the way to go.
Thanks very much, John. I'm sorry, we're going to need to close off the questions there, just given our time. And I'd really like to thank John, Natalie, Paul, and Julia for providing us with some really interesting insights to even to the projects they've been working on. And I think what all have shown is that there are some low-cost approaches to improving level crossing safety. And, we're really keen to see some of these projects actually roll out onto a bigger scale. You've all been a fantastic audience that have tolerated some technical glitches and binging with real grace, and I really appreciate it. Clearly, this is an area of interest for people, with more than 500 people on the line. We will therefore organise another knowledge share session in a few months' time. If you've got any ideas or projects that you think would be great to share with people across the country and New Zealand as well, please email them to info@tracksafefoundation.com.au if you've got some suggestions. I'd really like to draw your attention to 2 free rail safety education resources that would be terrific if you could take to schools and preschools that you have connections with. You can find all the information on our website, and it's really about starting that rail safety journey early so that hopefully the generations to come will actually have better behaviour around level crossings, know what to do, and also by the time they're in that space, the infrastructure and technology around it will also be keeping them safe. So please send through your ideas. We'd really appreciate it, and we'll convene another knowledge share session, hopefully without the technical glitches, in a few months' time. So please keep an eye on our communications for details about that. So thank you all for joining us, and I look forward to seeing you next time. Good afternoon.